What's up? What's up? What's up? It's your boy, the network. Today's topic is section 3.32, Explain BGP attributes and best path selection. This is a topic in the CCNP route exam. This will be known as the CCNP enterprise exam next year. This is most likely a topic that will be in that exam as well. We may split this up in two videos because this is a lot of material in this. Let's go ahead and take a look at the exam blueprint, see where we came from and where we're headed. Hashtag labeveryday. Here go the exam blueprint implementing Cisco IP routing exam code 300-101. The exam code will also change, and so will these topic numbers. But most likely, I guarantee you, explaining BGP attributes and best path selection will be in the CCNP enterprise exam. So just because there's a different exam code, know that this topic will most likely be in the CCNP enterprise exam as well. We just wrapped up the section 3.31C private AS. Today, again, we're doing explaining BGP attributes, and then we're finally going to move on to VPN technologies. Yes, we're finally wrapping up routing technologies or layer 3 technologies. So what are the BGP attributes? Let's talk about BGP first of all. BGP is a routing protocol, right? It is the only routing protocol that is on the internet. The internet is basically several networks intertwined within each other, or internetworks, and it is the largest network in the world, the internet. That's what they call it. What are the attributes? So we're breaking this whole thing down, right? That's what BGP is. What are the attributes? Well, you know how we have different routing protocols, right? EIGRP. We also have OSPF. There's RIP. Those are considered internal routing protocols. Those are routing protocols that we use within an intra-network. So like it could be your corporate network or something like that. That could be using an internal routing protocol. BGP would be considered an external routing protocol, even though we can use it internal as well. But they all use, in order to find the best way to get somewhere, they use what's called metrics, right? So like, for example, RIP uses hop counts as a metric, right? EIGRP uses bandwidth and delay as metrics, right? Well, BGP doesn't use metrics. It uses attributes. We are going to go through these slides and talk about what each of those attributes are. Some of them may or may not influence the best path to get somewhere, but that's what also we're going to talk about, the best path selection. How does BGP figure out the best way to get somewhere, right? Now, other routing protocols like EIGRP and OSPF, they do what's called load balancing. If they have like 3 ways to get to one city or one network, right? They can load balance between all 3 of those. In other words, take all 3 ways evenly or unevenly. You can take route 1 all the time, or 20%, 25% of the time, and the other 2 50% of the time, and 25% of the time, whatever the case may be. BGP always selects one path. It could have 500 ways to get somewhere. It will pick one path to get there. That's what BGP does. Let's go ahead and head over to the slides for some more information. So again, here are some fun facts about the path selection, right? BGP path selection is done through the best path algorithm, right? Yes, that's what they call the best path. OSPF uses the Lightfoot algorithm, and EIGRP uses the dual algorithm, DUAL, which is diffuse update algorithm. A best path uses various attributes, like we've mentioned, and we're going to go over them. Now, those attributes are separated in different categories. We'll talk about that as well. Various attributes assigned to each route and chooses one as a best path attribute on those attributes. BGP, again, chooses one path by default. I'm gonna keep telling y'all this. It could be 500 ways to get somewhere, 600 ways, 700 ways to get there. We are going to choose one path. But you can use the maximum paths router subcommand to load balance, just like EIGRP, apparently. Now that I didn't really know. The maximum paths you can load balance over BGP is 6. However, by default, BGP picks how many paths? Do you know? She don't know. One path. My daughter probably knows that one. Okay, so here are the most of the attributes. Now, some of them we are not going to go over because they're not applicable. Some of them are reserved. I will show you a complete list of attributes. However, these are the ones that we are really concerned with, and they are separated in several categories. So you can use this chart. You can Google this chart. There's several charts that are like this, but again, they are separated in different categories. We have, first of all, let's start from the top, right? We said we're going to discuss the attributes of BGP. They are separated into 2 subcategories, and then we'll have subcategories, if you want to call it that, right? So when well known and optional. right? The well-known ones are the ones that are well-known. They are the ones that are known by every type of router. You can have a Cisco router, they're going to know about this attribute. You can have a Juniper router. You can have a Huawei router. I don't know if I'm pronouncing that right. You can have a uh, any other vendor, they will know this type of attribute. That's why they call these well-known attributes. Now, these are the optional ones. Now, what do you think those are? Those are the ones that are optional. They are not. They may or may not be recognized by other routers. Those are the optional ones. They may or may not be recognized by BGP routers, but the well-known ones are known by everyone, right? Now we have these subcategories. I guess I'm gonna call them that. We have the mandatory ones. The mandatory ones, they must be present in all updates. Mandatory ones are present in all routing updates for BGP. Those are the ones that are mandatory. So we have, obviously, you got three right there, right? AS path, next hop, and origin. We're going to go over those in depth. That's why I said we may have to split this up in two videos. Those are the ones they must be in the BGP BGP update. Discretionary are the ones that may or may not be present in a routing update. So let's go ahead and take a look at those well-known mandatory and discretionary ones, right? So we got the well-known mandatory BGP updates. Again, these must be recognized by all BGP routers. I don't care if you have a Juniper router. Let's see if I can think of one right now. Palo Alto. There's another one. Palo Alto. I had to go back in the memory bank for that one. It could be a Palo Alto router, whatever. Anyways, they are recognized by all BGP routers and are present in all BGP updates. These are the examples: AS path, next hop, and origin. Those are the well-known and mandatory ones. So you will see this, and I don't care what kind of router you have. They are well-known and mandatory. Now, the well-known discretionary ones, these guys right here, so local and atomic aggregate, those must be recognized by all BGP routers, but they don't have to be present in all updates. So when we say mandatory, that means they must be present in all updates. We say discretionary, they don't have to be in all the updates. We say well-known, they are recognized by all. That's why they say well-known. They're recognized by all BGP routers. I don't care what vendor you have. Now, the ones that are well-known discretionary are local pref, or short for local preference. This is just the attribute, how it's written in iOS or in CLI. And then atomic aggregate, that is also a well-known discretionary BGP attribute. Now, these are the different types of attributes that BGP takes into consideration when passing along BGP updates. Now, these are the optional updates. Again, we said optional are the ones that are we have optional, right? We got the optional BGP attributes, right? They're divided into two subcategories: transitive and non-transitive. Transitive means that the update will be passed on. Non-transitive means it won't be passed on. So if you notice, optional, transitive, these are the optional transitive guys, and these are the optional non-transitive attributes. Again, we're not going to go over every single one of these. We'll go over the ones that really influence the best path algorithm, or the best path selection, right? So we're going to first start off with optional transitive. So when we say optional, we said that they may or may not be recognized by a BGP router, right? Now, when we say transitive, that means the update will be passed on. That's what we mean by transitive. It will be passed on. So if it's not recognized, it's marked as partial. Now, these are some examples of an optional transitive BGP attribute: aggregator and community. Again, we'll talk about those a little bit more in depth in the next couple slides. And then we have the optional. Well, we said what optional were. They may or may not be recognized by BGP router, right? Non-transitive means it's not passed on to another router. So again, optional non-transitive is may or may not be recognized by a BGP router, and it is not passed on to another router. So this you may or may not see on a router or not, but for the most part, the well-known ones are the ones. These three are the ones we are really concerned with. We're concerned with the other ones, but they consider these first when trying to determine the best path to get somewhere for using BGP: AS path, next hop, and origin. Sorry for jumping around here, but again, optional non-transitive. This is kind of like on the bottom of the barrel when it comes to selecting the best path algorithm or selecting the best path somewhere. Now, this is separate from the best path algorithm, because there is steps to figure out what the best path is. But these are some attributes that BGP uses to figure out the best way to get somewhere. Again, non-optional, non-transitive may or may not be recognized by a BGP router. That was optional means, and is not passed on to another router. That is non-transitive. These are the examples: MED, originator ID, and cluster list. I'm gonna fire up Boston Netsim real quick so y'all can see um, how to determine or how to look at each one of these attributes. Matter of fact, I've got it fired up in the background real quick. Let's talk about these attributes a little bit more in depth here, right? So again, now this topic, section 3.32 says we need to just explain BGP attributes and the best path selection. That's why we're not going to go too much in depth. We're not going to do any labs or anything. However, I will fire up. I've got the iOS in the background, so y'all can just point out the attributes and figure out what they are. Because all we needed to do here was explain. We don't need to configure and verify. Although, if you really want to know this stuff fully, you want to configure and verify. But this is really, if you want to know this stuff, this is more of a CCIE topic. So the AS path. This attribute here says it's an ordered list of ASNs to which the update has passed. So if we has passed, so we got a let me give you an example. AS path, right? So we're going to talk about AS path. So I've got this lab here. This is the one we used in the 4-byte ASN number, right? Or ASN lab. I'm not sure if I uploaded it or not, but I will do that after this. So we've got 3 routers here: router 1, 2, and router 3, right? Router 1 sitting in AS1, router 2 is in AS2, router 3 is in AS3, right? So as you can see here, I already ran show IP BGP, right? And this is what we use to to talk about the best path algorithm, right? This command right here is very important. You can do IP BGP some, but this one is very important, so we can point out each one of those. The AS path, so for example, right now we're consoled in the router 3, right? Now, he's got the network. He's got this interface, FA00, right? That's sitting, that interface is 10.0.0.6, right? That is the interface for that, right? So IP interface brief, right? FA00 is 10.0.0.6, right? Now, we run that show IP BGP again, right? He says he's advertising this to the other guys, right? Now, if we go to router 1, if he needs to know how to get to that area, to that interface, we're going to go into router 1. I've already ran that command so y'all can see. To get there to the 10.0.0.4 network, which is this right here, he says to get to the 10.0.0.4 network, the path, this is where AS path is located, under path. I don't know why they just put AS path, but right there, that's the AS path. The path to get there is to go to AS2, which is right here, and then you'll get there to AS3. And that is what the AS path is. Simply put, that is what the AS path is, right? It is an ordered list of ASNs through which the update has passed. When a route is advertised, the AS number is prepended. So every time you pass something on, he's going to say, okay, he adds his AS number. So in other words, AS2 added his to the path and added it to, passed it on to router 3. That's how come he was able to see AS2 and AS3 in the AS path there. That is the AS path, right? It's used to prevent routing loops. The route is ignored if a router sees its own ASN. So if router 1 saw, let me go back to this again. If router 1 saw his own AS in the path to get there, he knows that's a loop. So he's not going to even have that in his path. So if there was, we're in router 1 right now. If he sees AS1 in that path, he knows that's a loop. Because let's say if it was 2, and then like say it was another 5 or something, like we had some other routers. I should have made more ASs in here so y'all could, to make a better example. If he had some other ASs in here, and then he all of a sudden saw a 1 in there, he's like, wait a minute, that's my own AS. That's a loop. So he's going to remove that from his path. That's a routing loop prevention mechanism. So the next hop. In eBGP, the next hop is changed by the advertising router. In iBGP, the next hop is not changed. So how do we determine or find it? In the next hop, same command. We use show IP BGP, right? And there's the next hop, right? So from router 1, for him to get to router 3, right? Or this network, the 10.0.0.4 network, right? To get to the 10.0.0.4 network, the next hop is 10.0.0.2. Where's that? 10.0.0.2. That's the next hop. So to get to this network right here, his next hop is there, that interface. That is how we, now a little bit more about next hops. Again, in eBGP, that was an actual external BGP network. The next hop is changed by the advertising router. So in iBGP, the next hop is not changed. Let's go ahead and take a look at the next hop from router 2's perspective. What's the next hop to get to this network? It's already connected to him, but let's see anyways. Show IP BGP, and the next hop to get to this network, right, 10.0.0.4 network, which is here. The next hop is 10.0.0.6. Where's that? That's router 3, right? That's the next hop, the FA00. So the way to get to this network, even though it's directly connected, the next hop is there. That is next hop. That's the next hop attribute. Origin is a mandatory attribute that shows how a specific route was introduced to BGP. All implementations in BGP must understand and accept the value of the origin attribute. This attribute has one of 3 values. Now, we're getting a little more in depth here with origin. eBGP specifies that the route has originated from eBGP session. iBGP specifies that the route is interior to the originating AS and is the most preferred origin type for a route. So he is going to pick, we're going to go into the official cert guide for what origin is for a little bit more information on that. We say that this is the best path that affects the best path algorithm, right? A BGP path attribute that affects the best path algorithm. This value implying that the route was injected into BGP. So how do we determine what the origin is, right? Using that command, right? Show IP BGP. Now, we look at origin. There's origin right there. We can tell if it's internal or external BGP by looking at this last row right here, or last column in the show IP BGP output. You see, notice there's an I there, right? That's what origin is, right? So we go back to this topology right here. Notice there's an I here, an I here. So that means it's internal, or I'm sorry, the origin code right here is IGP, so internal. So this path right here, so let's go to router 3 and do that again. Show IP BGP. I and I. So that's what the origin code. The origin is it's an internal gateway protocol, and IGP origin update. So again, specifies the route is interior to the originating AS and is the most preferred origin type for a route. That's what the I stood for. Now, if there was an E, this would specify that it originated from an eBGP session. Now, again, we're not going to go over all the attributes. We may do a part 2, may or may not do a part 2 in this. We are just going to talk about the attributes that affects the best path algorithm. Now, here's the discretionary BGP attributes. What do we say discretionary was? They don't have to be present in all updates. Well known means that it's recognized by all routers, but discretionary means they don't have to be present in all updates. So these are present in all updates. These are not. These are the discretionary BGP attributes, right? Local preference is a discretionary BGP attribute. It's used to send updates to iBGP peers through a preferred path when there are many paths to a destination, right? Now, I like to think of local preference as like the, I don't know if y'all into listening to R&B music or Black Twitter even. Chris Brown and Lil Duval were basically dragged through Twitter because they made some comments about their preferences in women, right? So that's what I like to think of the local preferences, right? This is a preference that these routers, this is a preference, like a preferred route that these routers choose to go, but it's locally within the AS. As you can see here, it says the local preference attribute is used locally within an AS and is not exchanged between external BGP routers. So this is just like a preference that he knows and keeps to himself, which is what Chris Brown and Lil Duval should have done when they made those comments. Anyways, the path having the highest local preference is preferred. So if we run that show IP BGP again, Well, and one more rule to that is the default local preference value is 100. Now, I have a really simple topology here, so we're probably not going to see any local preference. But if we did, it will be located in this row right here. You run show IP BGP, you will see some random numbers here. The default local preference again is 100, and you will see it here. Here, let me show you another example of that. The local preference would be here, default 100, 100, 100, right? Now, those are all the same. If they're all the same, that means we need a tiebreaker, right? That's when you go down the best path algorithm to figure out, to kind of break the tie here. But again, local preference, the default is 100. So when you run show IP BGP, it will be located in this row right here. I'll show y'all again. This row is where we'll have it. We have a very simple topology. That's why I don't have any here. So that's local preference. This is a discretionary BGP attribute. Atomic aggregate is used to inform downstream neighbor the path information that may have been lost for specific routes. This loss is caused when more specific paths are aggregated into less specific paths. So this is kind of like route summarization, but for BGP when you say aggregate. Again, we're not going to go too much into these other attributes. Now, these are the transitive BGP attributes. Again, transitive is when these are passed on, right? Transitive is when a BGP route update is passed on. That's what transitive is. Non-transitive means it's not passed on. And easy to remember that is, think of the word trans as like short for transfer, right? Transfer, we're transferring information or passing it on, right? So transitive means we're transferring it. Non-transitive is we're not transferring, we're not passing on the routing update. That's one way to remember it. So when we're talking about the transitive BGP attributes, aggregator is a router ID that is responsible for aggregation, right? This attribute is not used in route selection process. That's why I don't want to talk about all of them, but it is one of the attributes. And community is an optional transitive attribute that defines the way group routers using features based on which the routing decisions like redistribution, preference, and acceptance can be used by them. I'm not going to go too far into this. Again, there are hundreds of attributes. I'll show y'all. We've got so many attributes. Yes, we're not going to go over all of them. I may not do a part 2 to this, but again, we're going to talk about the most important ones, which are probably the top, I say the top 10, 8 to 10. Those are the ones that we are really going to cover. Notice these are the optional transitive. Those are the optional non-transitive. And then we got these other ones that I have not discussed. Those are really, if you want to really get in depth with BGP, and we're not going to do that for this because this is just a CCNP video that I created. These are the non-transitive BGP attributes. Originator ID is optional, non-transitive. It's 4-byte attributor 4-byte attribute created by the route reflector. I forgot that. I got this from somebody's stuff. The attribute, shout out to Journey to CCIE.com or .blogspot.com, I think it was. The attribute carries the router ID of the originator of the route of the local autonomous system. Therefore, as a misconfiguration, if a misconfiguration causes routing information to come back to the originator, the information is ignored. So it's kind of like almost finding a routing loop, basically. That's what it sounds like to me. MED is a multi-exit discriminator. We can find that. Now, this is another confusing one. It's used to influence the inbound traffic from a neighboring AS, suggests to neighboring AS which path to select for traffic bound to your AS, not advertised beyond the neighbor AS. And we can find that using show IP BGP, right? But it doesn't say MED. You would think they would have done that, but no. MED is actually just metric, and that's where you would find that. Now, this is an MED. This column right here is MED. So if we look at that output, notice it says just metric. This is MED. That's where that information will go. So you run show IP BGP. Again, it's going to be in that row right here. That's where that information is found. So this is the best path selection process. I'm not going to go too far into this, but one way to remember it is this mnemonic in Voila Omni, right? So we go through this anytime we have multiple ways. So anytime we have multiple ways to get somewhere, whenever we're presented with many ways to get somewhere, we use this best path selection process to figure out the best way to get somewhere. So when it starts looking like this, when we're having to select best path, we use this process to figure out the best way to get there. First, we say, is the next hop reachable? So next hop, right? When we do show IP BGP and you see a next hop on that output, we need to find out if it's reachable. If it is, then that's what we're going. Then we just move on to the next step. If it's not, if there's no route to reach that next hop attribute, the router cannot use this route, right? Then we go to W, which stands for wait. I haven't talked about this, right? Wait is a Cisco proprietary feature. It's not really an attribute. However, Cisco routers use this number to figure out the best path. So whichever route has the highest wait, that's the path it's going to use. Cisco routers really use this. So it's kind of it kind of is an attribute, it kind of is not an attribute. It's kind of confusing when it comes to this attribute right here. And then we choose the local preference. Remember we talked about local preference, the Chris Brown, Lil Duval attribute. Whichever has the highest local preference, that's the route we take. If they're all the same, so we kind of go all the way down here. If it's like, is it reachable? Yes. Is the weight the same? We just kind of keep going down, right? Is the weight the same? Okay. If it's not bigger, if it's the same, then we go to the next one. If it's the same, we go to the next one. If it's the same, we go to the next one. We keep going all the way down until we figure out the best path. If we have the bigger weight, then we go with that route. If somebody has the biggest local preference, we go with that route. Locally injected routes, that's what L stands for. If the locally injected route is better than one that is learned from us, then we choose that route. If not, then we go to the next one. If the AS path length is the same, this is almost like a hop count. If we have three, like in this topology that I just showed you, this has three ASs, right? So if this is kind of like, it's almost a hop count, 1, 2. So we go to route 3, or actually router 1. We go to router 1 to get to router 3. To get to AS3, he has 2 hops to get there. If he had another way to get there and it's also 2 hops, then now he would need a tiebreaker. If he has just one way to get there, then he'll pick the one that has the shortest amount of ASs to get there. And that's for AS path learned, right? The AS path length. Then we go to origin. It prefers internal gateway protocol over EGP. So it'll pick a route that is an internal gateway protocol over an external gateway routing protocol. MED, it picks the smaller MED. If those are the same, then we go to the next one. You choose the neighbor type. We prefer eBGP routes over an IBGP route. If that's the same, then we go to the next one. The IGP metric, we choose an IGP metric over to the next hop. The number that has to be smaller. So the smaller IGP metric has to be chosen. If those are the same, then we go to a route a tiebreaker, which is the router ID. These are the tiebreakers. It'll choose if we get down to the last one that I just showed you. It chooses the next tiebreaker, the oldest, longest known route, eBGP route. If those are the same, then it's going to choose the lowest neighbor BGP router ID. If those are the same, so you just keep going down, and that's what BGP does. It just keeps, if those are the same, it goes to the next one. If those are the same, it goes to the next one. If those are the same, it goes to the next one. It uses those as tiebreakers. And then finally, it chooses the lowest neighbor IP address. And that's what it does when it chooses the best path. And that's how the best path algorithm works. Now, again, if you need more information on that, I suggest pulling out the official cert guide. I'm just kind of trying to explain the BGP attributes and the best path selection very briefly. Now, this could have been an hour-long video. I was just doing a brief explanation on the BGP attributes and the best path selection. I may or may not do a part 2 of this just to get more in depth, but I'm still in the process of taking this exam and stuff, and I just needed to try to do a little short explanation. So that is my YouTube page. That is my Twitter handle. If you like this video, please go ahead and click the like button. Please leave a comment below on how I could have gotten more in depth. I know this was a very, very brief explanation on the BGP attributes. I'm going to do a little bit further reading. I tried to do a lot of reading on this, but I was, going through all these other topics as well. Please give it a comment below on what I could have talked about a little bit more as far as the attributes go, or if I made any mistakes. Go ahead and share this video. Hit the subscribe button if you want to see more of this stuff. Hit the notification bell if you want to see if you want to know exactly when I upload these videos. For now, please comment, like, subscribe to the network.